Hey everyone, today I'm going to be showing you how you can make a telescope with gallium. In order for a telescope to work, you need to take a large area of light and focus it down to a smaller area. You can do that two ways, with a lens or with a mirror. The lens version uses a lens to converge light of a large area down to a smaller, brighter area that we can see in an enlarged image. But the problem with lenses is that they focus different wavelengths of light differently. So you kind of get a prism-like effect. So the better version of telescopes uses mirrors. In reflector telescopes like this, there's a parabolic mirror that focuses a large area of light to a smaller area to let us see an enlarged image. But it's really hard to manufacture perfect parabolas. It can take years in some cases. I have a 6-inch parabolic mirror here that cost me several $100s. They're very expensive. It's because to make these mirrors, they have to meticulously grind glass into the right shape. For large mirrors, this can take years sometimes. But what if there's a better way to make a perfect parabola? Well, it turns out there is. If you just spin any liquid in a uniform gravitational field, it forms a perfect parabola. Okay, so I just have this turntable here. I can turn it on. And look at this cool shape it makes. Let's look at it in slow motion. Using the buoyant forces and the force of gravity, you can find that the height of the liquid at any point is just 1 over 2 times the gravitational constant times the rotational speed of the liquid squared times the radius squared. So you can see this is actually the definition of a parabola, some constant times r squared. So we know how to make a perfect parabola. Now we just need some reflective liquid metal. Some mercury would work great for this, but let's try something a little less toxic, like gallium. Gallium's a shiny metal that can melt in your hand. I have some gallium here, and I've also put it in some dilute hydrochloric acid that helps it not oxidize on the surface so it stays shiny. So let's see if we can get it to form a perfect parabolic mirror here. As I start to spin the gallium, watch how the image goes from a flat reflective image of the camera to a distorted image of me looking through the camera. This tells us that the focal length has moved far from the gallium, and the faster I spin it, the smaller my image gets. Look at this, it works. So the faster I spin it, the further the focal point. So you can see my image gets smaller and smaller here as I increase the speed. Look how cool this looks. I can actually change the focal point of the mirror just by changing the rotational speed. So this should work just like a lens to focus a light source to one single image of that light source. So I should be able to focus my camera light to a single image of the LED. Just have my phone that's going to act like a point source of light that's going to shine down on our parabolic mirror here. So we're going to look at the light reflecting off the liquid mirror at the bottom that hits the sheet of paper from below. So right now we can see that the light is all spread out in a big circle. That means the liquid's spinning too fast because the focal length is too long. If I slow it down a little, we can focus this light to a single point, just like a magnifying glass with the sun. Mine looks a little jittery because I have some bubbles in here and some little floaters in my liquid. And my rotating table isn't exactly balanced, so there are some slight imperfections from the little waves that happen from it being unbalanced. This totally works. We can get an almost perfect focus point of light. So the focal length of this mirror is just the gravitational constant divided by 2 times the angular speed squared. And believe it or not, this is actually what they use in real telescopes called liquid mirror telescopes. They have a slowly rotating plate of mercury or gallium alloy, and they spin it to form a perfect parabola that they use as the telescope's mirror. These types of telescopes are beneficial because you can have a huge mirror that costs around 25 times less than a glass mirror. But as you can tell, one problem with these mirrors is that they have to be pointed straight up. So it's pretty amazing that you can use something so simple to create an almost perfect parabola that you can even change the focal length of if you need to. And thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe to my channel if you haven't yet. And you can also hit the bell so that you're notified when I release my latest video. And thanks for watching, and I'll see you next time.